All right, everybody, we're gonna tie some loose ends in with some new ends. We've got a problem here where we're making a precipitate. We're mixing silver nitrate with sodium sulfate. Ladies and gentlemen, ions. Always need ions. What's the silver ion? Always. Silver. Ag+1. We have to know that. Nitrate. NO3-1. NO3-1 will not be part of the precipitate. So I really don't need this table. Whatever product has nitrate in it is not the precipitate. We know this. Nitrates are never precipitates. Sodium is Na+, sulfate, SO4 2-. Now you're ready to do your mixing and matching of your ions. We've done so many double replacements. I hope we're getting comfortable with it. AgNO3 is a 1-to-1 ratio. We're doing A right here where it says A, AgNO3. And these are solutions, right? Yeah. In this class, our solutions always have the same liquid dissolving the solutes. And what is that liquid in this class all the time? Water. How do we indicate that these solutions are in water? AQ. And the other one is Na2, SO4, also a solution, also dissolved in water. Reacts to give. Ag is now going to be with SO4. Ag2SO4. I need two silvers for one sulfate, and that is our precipitate. Solubility rules do verify that. Sulfates are always soluble except with silver, so that's a precipitate. And the other one is just sodium with nitrate. That's AQ. And then it's time to balance. We know we have to have formulas that are balanced before we balance an equation. And I think this one gets a couple 2s to be finished. 2 silvers this way, 2 sodiums this way, and we're done. So that's part A. And then the fun begins. We have everything we need. No, we don't have everything we need here. Now we do. You have a volume and a big M. Uh-oh. What is big M really? Moles per liter. What do we have to do with our milliliters? Yes, 1 liter for every 1,000 milliliters. Okay, that's going to be 0.0253 liters. And once you showed the work on the first one, I would be okay with you just saying 0.01824 liters. But you got to show the work on one of them, okay? I showed it right there, right on the question. That's showing work. You can do that. And now I can get moles. I got moles per liter and liters. That's straight up multiply, right? And we're talking AgNO3. So let's just do it right underneath. You've got 0.02253 liters times 0.154524, sorry, moles per liter. And I'll await your answer on that, and we'll do the other one here. That's going to be 0.01824 liters times 0.1391, and I will pause and get your answers shortly. Almost killed the video there. We're back though. We worked out the moles for silver nitrate by multiplying the volume times the molarity, and we got this number here. Then we did sodium sulfate here, volume times molarity. And some of you are starting to think that this one is going to run out first. You might be in for a surprise. Just follow the steps and you can't get wrong. You can't go wrong. Calculate the theoretical yield in moles of precipitate from each reactant. This is two separate calculations. Yours will be two separate calculations. We'll do one in green. Remember, the green chemical was AgNO3. This is part B. You have 0.00343357 mole AgNO3. Moles of substance A. Can I get to moles of a different substance? And which particular substance do we care about in this question? What other substance do I care about in this question? No, the other substance I care about in this question is indicated in part B. What the other substance is. What is the other substance in part B that I am asking about? Yes. Yes, he said silver sulfate. How did he know? It's not listed in part B that we're looking for the moles of silver sulfate. How do you know it is silver sulfate? Well, the magic word that nobody has said yet, I think somebody said it, but it was very faint, was precipitate. I only want to know about the precipitate in part B. It says right there. So the precipitate is the silver sulfate, S. That's an S. So stoichiometry says you make one Ag2SO4 salt. I could have written precipitate there, right? I think it's just faster. I'm just going to change it to PPT. I didn't change anything, did I? For every two AgNO3s. And these numbers, the 1 and the 2, what are they called again? Coefficients. What's the only thing coefficients are good for? Moles of one substance, moles of another. You got to have moles to start with, or else you're not using coefficients. And we're going to get that number cut in half. 0.0017. Oh my God, I need help. 1678 mole PPT. Do it again for the other substance, which will be in baby blue. The other substance is silver nitrate with sodium sulfate. Na2SO4. You have 0.0025318 moles of Na2SO4. You're going to make 1 mole of PPT. I forgot to put the word mole in the top one. For every 2 mole, or 1 mole, 1 mole Na2SO4. I know the answer to this one. Got it covered. 0.0025318 mole PPT. And that number is irrelevant. That baby blue number is absolutely meaningless right now. And how do I know this? How do I know that baby blue number that I just calculated is a total waste of time? I had to calculate it to figure out it's a waste of time. It's bigger than the other one. This is the theoretical yield right here. It is the smaller of these two numbers. This is the theoretical yield, which means the chemical it came from is called which reactant? The theoretical yield comes from the chemical that runs out. What is the name of that chemical? Limiting reactant. That is the answer to C. No. So this was the answer to C right here. But if there was a question, which one is the limiting reactant, that's also part of C, you know. Okay, this is meaningless. And it's meaningless because it comes from the excess reactant. Excess meaning extra. There you go. Not quite done yet, huh? That's why this is a double activity. So far, we got theoretical yield. We got an actual yield too. Yeah. But my units don't match. My theoretical yield is this. It's in moles. My actual yield is in milligrams. You got a couple options. Which one do you want to choose for D? Remember, percent yield equals actual over theoretical times 100. Units must match. They don't match now. One's in milligrams, one's in moles. Talk to me. Need help. What do I need to do? She wants to change moles, my theoretical yield of moles to grams. I like it. To do such a thing, she's going to need the formula weight of the theoretical yield of precipitate. So first up, FW. The only FW you need in one of these solution questions. You don't have to do formula weights early on because we got moles in the solution already. So formula weight, we got two silvers, 2 times 107.9. Did I get that number correctly from the periodic table? My memory isn't quite what it used to be. I got it, okay. And we also have sulfur 3207, is that correct? Sulfur 3207? You're gonna make me walk over to my periodic table?
Yeah.
Okay, and then 4 times 16, is that right? And somebody's probably got it already for me. If not, I'll pause. Back. We are back now. All right. So what happened was we had to figure out the formula weight for our precipitate, which is silver sulfate, if you forgot. Ag2SO4. 2 silvers, 1 sulfur, 4 oxygens, 311.87 grams per mole. Theoretical yield is going to convert from moles to grams using the molecular weight like this. And what kind of answer did we get? We are back to the big finish. We have this many grams in our theoretical yield. That's how much we could have made. Yes, and I noticed this happens a lot when I make up these questions right before class, and I do my best to make sure you don't get more than 100% yield. I failed. This is 535 milligrams. I hope you agree. You can't get more than 535 milligrams in this question. It's impossible. My question was wrong. Easy fix, please fix your question. The actual yield was 521 milligrams. Please fix that right in the question. Actual yield was 521. I'm gonna make sure it's very clear. 521. Okay. And now we can calculate the percent yield. The most you could have made is 0.535 grams. So I got 0.535 goes on the bottom, right? And where'd this 0.521 come from? There's a conversion going on there. You should show the work for. Yeah, I don't like hearing that. It's correct. I said times 1 gram for every 1,000 milligrams, right? Yes, there's your division, but I don't like the way you said it. Don't take it personally. Everything's a conversion factor. That way you never have to say divide or multiply. It's always multiply by conversion factor. And we got 0.521. And it's a good yield. What kind of yield is it? It's in the 90s? No? Two more. So 3-1. Final answer. Finally. Epic problem. And you make sure you have all that down for 2 activity points. I think we're done.